Okay, number 28, while vacationing in the mountains, you do some hiking. In the morning, your displacement is S vector morning equals 2,000 meters east plus 3,000 meters north plus 200 meters vertical. Continuing on after lunch, your displacement is S vector afternoon equals 1,500 meters west plus 2,000 meters north minus 300 meters vertical. A, at the end of the hike, how much higher or lower are you compared to your starting point? And B, what is the magnitude of your net displacement for the day? So let's start with what we know. What we know is all these two vectors here, the S morning and S afternoon. We have all of these, and what this looks like on a graph is we start out here at the origin. We move 2,000 meters east, 3,000 meters north, and 1,500 meters west. And you can see that this is actually the same as negative 1,500 meters east. So instead of 1,500 meters west in our calculations, we're going to be doing negative 1,500 meters east. And then we do 2,000 meters north. And what we're trying to find is basically this vector here, and then also a vertical vector that we can't really draw very well on a piece of paper, but we'll be able to find it later. So we're going to start out with A. At the end of the hike, how much higher or lower are you compared to your starting point? And this is actually, we're going to be finding the vertical displacement. And this is super easy. We're just going to take those 200 meters vertical plus the negative 300 meters vertical, which is the same as just subtracting. And we get negative 100 meters vertical. And so the hiker, U, is 100 meters below where they started. And so for B, we're actually going to do this kind of in three parts. What we need to do is we need to take these vectors and these values and find the displacement between them. So we're going to start with 2,000 meters east plus negative 1,500 meters east, like we decided earlier. We get 500 meters east. Then we take 3,000 meters north plus 2,000 meters north equals 5,000 meters north, and we already got the vertical altitude earlier. And so we're going to start with a northeast direction displacement. And so we're going to use the Pythagorean theorem. The reason we're using this is because we have a lot of right triangles here. And it really just makes sense to use the Pythagorean theorem for this line because we have so many right triangles. And so we're going to take C equals the square root of A squared plus B squared. So we're going to have 5,000 meters north squared, which is the displacement from up here, plus 500 meters east squared, which is our displacement from here. And we're going to get 5,024.94 meters. And we're going to leave this unrounded for now. That's really important. Then we're going to get the northeast and vertical displacement. And we're basically going to use this and this in our Pythagorean theorem. So we're going to go D because we don't want to use C again. The northeast displacement squared plus the vertical displacement squared. And this negative is going to go away. And so we end up with 5,025.93 meters. And because all of our other values had 1 or 2 significant digits or less, we're going to round that out to 5,000 meters or 5 kilometers. And our learning goal for this particular question was just practicing our vector algebra from week 3. We're basically just practicing all the subtraction and addition, and a little bit of multiplication with the exponents here. But really we were just practicing our vector algebra and seeing if we really understand what it means to have these directions and what it looks like on a graph, and how to find these displacement values. All right, so that was 28. Thank you very much, and I hope you have a lovely day.